Being at the cutting edge of science comes with some amount of risk, especially when radiation is involved. Luckily, we have a new crew that's built to take on the rough assignments: robotic dogs. Today, we're going behind the science at Los Alamos to see one way these four-legged robots are keeping workers safe while getting critical work done. I'm Chris, your host. This is Dan. He's the robot guy here at Los Alamos. He's going to tell us exactly how the lab is using these mechanical mutts. Dan, thanks so much for having us today. Can you tell me what brought you to the lab?
My time in the Marine Corps using robots to mitigate hazards, specifically high explosives, prepared me to use robots here at the laboratory to mitigate even more hazards.
Cool. What brings us to this space today?
So we're here today to show you where we do our R&D work for robots here at the laboratory.
They're Boston Dynamics robots, right?
They are. They're Boston Dynamic robots.
Okay, cool. Shall we go see some of these robots in action?
Yeah, let's do it.
What are you training them to do that sets them apart? Like, can you just buy one off the shelf?
The secret sauce in our team is that we take autonomous coding and then we mate that with robots and hardware for a specific mission or situation. In this instance, the robot's taking its surroundings in, it's building a model, and then conducting its task that we want it to do, which is survey floors for radiation contamination.
And this is normally somebody would go in with a handheld, right, and kind of swab.
Some of this work might be radiological control technicians, RCTs. Their job is long, and to have a system that they can employ for a long duration really allows them to get more work done. And anytime I see people getting into PPE, I'm like, we can solve that.
Like if you can send a robot in instead of a person.
Exactly. Currently, we're focused on radiological hazards, but being able to separate workers from high explosive hazards or chemical hazards is just as important.
Yeah.
So now that we've kind of looked at how it operates, I'd really like to show you the literal nuts and bolts of how we put this together and assemble the payloads.
Okay, great.
Yeah.
This is Dylan. He trains robots here at the lab.
Right now, I'm just reassembling the prototype setup for the new computer for our system.
How is that different from the handhelds we saw earlier?
Where it differs a lot with the handheld is basically it's routing to this card stack here, and that's enabling the computer to actually pull data from the detector. The detector itself is just an analog device. That card stack basically converts that analog signal to digital that the computer can actually understand.
And another big difference in between the two is they're detecting different types of radiation contamination. You want to try?
Yes, I'd love to. If I push really hard, will it run? I'm not going to do that, but okay, I'm not going to do that.
The foot on it can move at 10 feet per second. In my team, they have this thing that I love to hear, and they know this. They say, hey, do you want to see something cool? And yes, I do. And then they have such passion for their work that they'll show it for me, and we're all elated on what we can get these robots to actually do.
Cool.
It's amazing.
What do you have planned for the future with the robots?
We are an autonomous mobile robotics team. And so not only are we going to use Spot, we're going to look towards using newer technology, maybe something that's humanoid or bipedal, drones, other types of robots to flex our capabilities here at the laboratory where they're most needed.
We've all seen these robots dance before, but it's way cooler to see what they're doing to keep people at the lab safe and to learn about where the robot team might take them next. Do you give them names?
We do, and we're taking the opportunity right now to rename them. Team vote was directors' names, so we're looking to name maybe Charlie, Aggie, Tommy. You're out there, so yeah.